Hello students, welcome back. Students, today we are going to discuss some lab preparations of salts. So first we have lab preparation of iron 3 chloride, that is ferric chloride. Iron 3 chloride is called ferric chloride. So students, we have learnt this, that ferric chloride is a water soluble salt which is prepared by direct combination, that is by synthesis. So students, method which is used for the preparation of ferric chloride is direct combination, or we call it what? Synthesis. So this is the method, and the chemical equation which is involved in this case, the chemical equation is that we heat iron with dry chlorine gas and we get a brown colored solid which is called ferric chloride. So on balancing we get this as the main equation. So this is how we prepare ferric chloride. So the main thing is how it is prepared and the balanced chemical equation. But students, in lab, how this is done? So first, students, we require chlorine, but generally the chlorine which we prepare is moist. Moist means it has some water vapor, but in this reaction we need what? Dry chlorine. So in order to dry chlorine, that is moist chlorine, we pass the moist chlorine through concentrated sulfuric acid. Now students, listen carefully. Concentrated sulfuric acid has great affinity for water. So that means moist chlorine mein se concentrated sulfuric acid will absorb all the water, because sulfuric acid is a very good drying agent. So here we use concentrated sulfuric acid to absorb all the moisture which is present. Now then what happens is, chlorine will not react with sulfuric acid, so we get dry chlorine. Now this dry chlorine is introduced into a what? Combustion tube. So this is a combustion tube which is preheated and has iron wire. So when dry chlorine is passed over this heated iron wire, what happens is iron and dry chlorine, they react to give ferric chloride. But at high temperature we get vapors of ferric chloride. So now these vapors of ferric chloride are then what? They are introduced to this conical flask where the ferric chloride is condensed to give a brown scale of what? Ferric chloride solid. So vapors are condensed into ferric chloride. But students, this ferric chloride is highly deliquescent substance, which means it can absorb moisture from the air. So in order to keep this ferric chloride dry, the tube is also attached with anhydrous calcium chloride. Why? Because anhydrous calcium chloride is a drying agent, is a powerful drying agent. So all the moisture will be what? Absorbed by calcium chloride, that is anhydrous calcium chloride, and therefore ferric chloride remains perfectly dry. So this is how we prepare ferric chloride in lab. Now students, ferric chloride, since it is what? Deliquescent, it absorbs moisture and becomes hydrated. So एक technique students ये भी हो सकता था, that when we heat what? This ferric chloride hydrated, तो moisture निकल जाएगा and you will get ferric chloride. But students, ऐसा theoretically हमें लग रहा था कि hydrated ferric chloride से भी हम ferric chloride directly बना सकते थे. But students, this is not correct, because when we heat hydrated ferric chloride, it is not only that moisture is removed, instead this chloride is oxidized into ferric oxide, Fe2O3. All the chlorine will be removed as what? HCl, and then we have what? Water also. So this is very important to note that ferric chloride is not obtained by heating hydrated ferric chloride. Why? Because on heating hydrated ferric chloride, we get ferric oxide, not ferric chloride. So students, this was a very, very important note. Now students, next we will discuss the lab preparation of zinc sulfate crystals, that is white vitriol. Dear students, zinc sulfate occurs as zinc sulfate dot 7H2O. So zinc sulfate occurs in hydrated form, and students, these hydrated zinc sulfate crystal are commonly called white vitriol crystals. So zinc sulfate is commonly known as white vitriol. Zinc salts are white, so we call this as white vitriol. Now students, how we prepare zinc sulfate? Now again, we have learnt that zinc sulfate, in fact all sulfates are water soluble, so zinc sulfate is also water soluble, and since zinc is highly active metal, the zinc salts therefore can be prepared by displacement or substitution reaction. So the method used for the preparation of white vitriol crystal is what? Displacement method, or we say substitution method. So this is, now in this reaction what happens, that we use zinc, that is say powdered granulated zinc, and when it is reacted with dilute H2SO4, what happens? Students, zinc is more active than hydrogen, so zinc displaces hydrogen and we get zinc sulfate. But since water soluble has zinc sulfate, so we get aqueous solution of zinc sulfate and hydrogen evolves. So students, this is how we prepare zinc sulfate crystals. But students, since zinc sulfate to water soluble, how we obtain zinc sulfate crystal? So what we do is that the solution of zinc sulfate is then crystallized. So that means we heat this solution till crystallization point, and upon crystallization what happens is that zinc sulfate crystals, they absorb certain quantity of water. So this process is called crystallization, and we get zinc sulfate 7H2O solid, and this is called white vitriol. So this is the chemical equation for preparation of zinc sulfate. Now how this process or this reaction is carried out in lab. So students, what we do in lab is that we take granulated or powdered zinc and we add this powdered zinc to dilute sulfuric acid taken in a beaker. Now what happens is that when we add zinc to dilute H2SO4, there will be effervescence in the solution, means bubbles bahar ko aayenge. That will be due to the evolution of what? Hydrogen gas. So we'll keep on stirring the solution until the evolution of hydrogen ceases. Now once the evolution, that is effervescence, ceases, we will stop adding more metal. Now then we filter the solution so as to remove any unreacted metal or any other impurity, and the filtrate obtained is collected in a china dish, and then the solution taken in china dish, that is, it will be of what? Zinc sulfate, is evaporated till crystallization point is reached. Now once the crystallization point is reached, the solution is allowed to cool gradually, and upon cooling, the crystals of zinc sulfate, that is white vitriol, they separate out. Now these crystals are then filtered off from the solution. Then we place them between folds of filter paper, and then we press the filter paper gently so as to remove water, and we get white colored white vitriol crystals. Now students, ferrous sulfate crystals are also prepared similarly. Ferrous sulfate crystals can be prepared by similar method. Now ferrous sulfate also is a hydrated salt and is called green vitriol. It is called green vitriol. And the method of preparation of ferrous sulfate is similar. That is, it is also prepared by displacement. So what we do is that we take powdered iron and we add it to dilute sulfuric acid. We get ferrous sulfate, but since ferrous sulfate is water soluble, so it will remain in the solution, that is filtrate, and the hydrogen escapes with brisk effervescence. Now the solution, that is filtrate, is then taken in a china dish and is heated till crystallization point is reached, and upon crystallization we get is ferrous sulfate crystals, and this ferrous sulfate, hydrated ferrous sulfate, is called green vitriol. Now students, next we will discuss preparation of some other water soluble salts. Dear students, generally water soluble salts are prepared by neutralization reaction. So students, what is neutralization reaction? Neutralization reaction. Now, so neutralization reaction is a process in which H positive ions of an acid are neutralized by OH negative ions of a base to give water. So generally we say neutralization is what? An acid reacts with base to give salt and water. But when we go into details of neutralization reaction, we find that it is not that we are getting salt and water, but actually in neutralization reaction, H positive ions of the acid, they are neutralized by OH negative ions of a base to give water only. So these are H positive ions of acid, OH negative ions of base to give water only. Now let me illustrate this, that why we are not writing salt and water, rather we are writing only water. So students, say if I take HCl solution and sodium hydroxide solution, now upon mixing what happens, that neutralization occurs and we get salt, NaCl and water. But now students, what is HCl? HCl is a strong acid, so in aqueous solution it undergoes almost complete ionization into free H positive and free chloride ions. Now students, what is NaOH? Sodium hydroxide is an alkali, and alkalis dissolve in water into what? And they dissociate into ions. So sodium hydroxide dissociates completely, and now the product which we get is what? Sodium chloride. But we know that sodium chloride is highly soluble in water, and in water it dissociates into ions, that is sodium and chloride ion. But at room temperature water is almost a non-electrolyte, so it is unionized. Now students, see, if you carefully observe, these chloride and sodium ions, they are spectator ions. Why we call them spectators? Because उनका अगर status before mixing और after mixing देखो तो they are same. Like chloride पहले भी free था, अब भी free था. Now sodium पहले भी free है था, अब भी free है. So finally we see that only H positive and OH negative ions, they are combining to give water. So that is why we say that in neutralization, H positive ions of acid are neutralized by OH negative ions of base to give water, or vice versa. Now a very important thing, students, whenever this neutralization process occurs, a certain amount of heat is released. For example, generally we say 57.1 kilojoules per mole heat is released upon neutralization reaction. So this heat is called heat of neutralization or enthalpy of neutralization. We call it heat or enthalpy of neutralization. And students, the most important thing about neutralization process or about heat of neutralization is that enthalpy or heat of neutralization remains same when a strong acid is neutralized by a strong base irrespective of the nature of acid or base. Now iska kya matlab hai? See students, when we take say NaOH and HCl, we get NaCl and water. How much heat is released? Because ultimately heat to isi reaction ki wajah se release hoga. It is what? Heat released is denoted by this sign delta H, and it is minus 57.1 kilojoules per mole. Now students, आप सोच रहे होंगे मैंने minus क्यों लगाया? Because heat released during the reaction is represented by negative sign. Now suppose if I take say some other acid like say sulfuric acid and then NaOH, the neutralization will take place to give what? Sodium sulfate plus what? Water. Now if this reaction is say splitted into the ionic reactions, then sulfuric acid is strong electrolyte, it dissociates or ionizes completely. Sodium hydroxide will ionize completely to give 2 hydroxyl ion and 2 sodium ions. Sodium sulfate is water soluble salt which dissociates completely. So we have these ions plus water. Now, so students, now you see that these are what? Just the spectator ions, because इनमें कोई change ही नहीं है before and after mixing. So we have only what? 2 H positive ions combining with 2 OH negative ions to give 2 water, और simplify करेंगे तो हमारे पास यही equation आ जाएगा that H positive OH negative gives 1 water. So since the main reaction still remains the same, the heat of neutralization of this reaction will be same. So that is why we say that enthalpy of neutralization of all strong acids by strong bases remains the same irrespective of nature of acid or base. So this was very important discussion about what is neutralization reaction. Now students, we will discuss how to prepare water soluble salts using neutralization reaction. And first we have preparation of copper sulfate crystals, that is blue vitriol. Now blue vitriol is copper sulfate dot 5H2O. So students, these are very important terms. Blue vitriol. Now how we prepare copper sulfate by neutralization reaction? So we have many possible reactions. We take say copper oxide, which is basic, and when it is neutralized by acid H2SO4, we get what? Copper sulfate plus water. So, or we have say copper hydroxide. Now hydroxide of copper is also basic, and when it is reacted with H2SO4, neutralization takes place to give copper sulfate and water. Now another possibility is we take copper carbonate, because copper carbonate is also basic, carbonates are slightly basic. So again neutralization takes place, we get copper sulfate plus H2O, and there will be effervescence due to evolution of carbon dioxide. So this is our first step. But out of these three reactions, कोई भी एक use कर सकते हो आप. So we have either copper oxide, copper hydroxide. Now what we do, so as to obtain crystals, now this solution containing copper sulfate, which is water soluble salt, so this solution is filtered so as to remove any insoluble impurity, and the filtrate is then collected in a china dish. Solution is then evaporated till crystallization point, and then solution is allowed to cool gradually, and upon cooling we get crystals of hydrated copper sulfate, and upon crystallization we get copper sulfate dot 5H2O, and this is called what? Blue vitriol. This is called blue vitriol. So this is how we prepare blue vitriol crystals. So students, please remember these terms. Blue vitriol is copper sulfate dot 5H2O, green vitriol is ferrous sulfate dot 7H2O, White vitriol is zinc sulfate dot 7H2O. Now next we will discuss preparation of sodium sulfate crystals. Students, sodium sulfate is a water soluble salt and it is also prepared by acid base neutralization reaction. But students, sodium sulfate is a salt of alkali sodium hydroxide and acid H2SO4. So since both are water soluble, the method which is used to prepare is called therefore titration. Now, so in this reaction what we do, we take base and then we neutralize it with acid and we get sodium sulfate. We get sodium sulfate. So this is how sodium sulfate is prepared. Now practically this is carried out by a technique which is called titration or volumetric analysis. Now acid is taken in an instrument which is called burette and we'll note the initial volume of the acid. Now then base is introduced to a titration flask with the help of instrument called pipette, and then to this basic solution we add few drops of phenolphthalein, and we know that when phenolphthalein is added to sodium hydroxide, the color of sodium hydroxide solution becomes pink. Now students, what we do is that we drop acid to this NaOH solution drop wise till end point is reached, and end point means जब ये जब सॉल्यूशन का जब पिंक कलर है वो डिसअपियर हो जाएगा, मींस कलरलेस हो जाएगा, उसको हम बोलते हैं एंड पॉइंट. एंड एंड पॉइंट इंडिकेट्स व्हाट? इंडिकेट्स व्हाट? complete neutralization. So we get sodium sulfate upon complete neutralization. So this is how it is carried out in lab. And then since sodium sulfate is water soluble, we filter the solution so as to remove any insoluble impurity, and we then collect the filtrate in a china dish. We heat it till crystallization point is reached, and then we allow the solution to cool gradually, and upon cooling we get white colored crystals of sodium sulfate dot 10H2O, and this sodium sulfate decahydrate is commonly known as Glauber's salt. So students, now we'll move on to the next topic, that will be the preparation of insoluble salts. Students, now we will discuss preparation of insoluble salt, and the first salt that we are going to discuss is lead chloride. Now students, generally water insoluble salts are prepared by precipitation method, or we call it double decomposition. So the method which we use for the preparation of lead chloride is double decomposition, or we call it precipitation. So in this reaction we take a water soluble salt of lead, and the only water soluble salt of lead is lead nitrate. Now to this we add either sodium chloride or hydrochloric acid. So when we add sodium chloride to this solution, the exchange of ions will take place between the two different salt solutions, and we get PbCl2. Now this PbCl2 is insoluble in cold water, so it precipitates out, so we get white precipitate of lead chloride, plus we have sodium nitrate. So this is how we prepare lead chloride. Now students, we separate these lead chloride crystals from the solution by filtration. Now then what we do next, that we dissolve these lead chloride precipitate in hot water, because we know that lead chloride is soluble in what? Hot water. So and then we crystallize the solution to obtain lead chloride crystals. So this is how we prepare lead chloride crystals. So the basic technique in the lab is same, that first we prepare lead chloride crystals, we wash the crystals with water, and then we dissolve the lead chloride in hot water and then recrystallize it in pure form. So upon recrystallization we get lead chloride, and when the solution is allowed to cool gradually, we get needle shaped crystals of lead chloride. Now students, next we have preparation of another water insoluble salt, which is calcium carbonate. Now students, calcium carbonate, since it is water insoluble, it is also prepared by the same method, that is double decomposition or precipitation. And for this we use what? A water soluble salt of calcium, say calcium chloride, and to this we add sodium carbonate. Now both are what? Water soluble salt, but when these two salt solutions are mixed, the exchange of radicals takes place and we get calcium carbonate, and this calcium carbonate being insoluble will precipitate out and solution will contain NaCl, and this precipitate is then removed by filtration and then is washed and dried to obtain crystals of calcium carbonate. Now the last salt which we are going to discuss now is sodium bicarbonate. Now students, generally sodium salts are highly soluble in water, but sodium bicarbonate is sparingly soluble. That means it is only slightly soluble and therefore can be prepared by precipitation. And how it is done? For this we take sodium carbonate, which is soluble in water, and then to aqueous solution of sodium carbonate, carbon dioxide gas is passed. And what happens upon passing carbon dioxide gas? That sodium carbonate changes to sodium bicarbonate. But since bicarbonate is less soluble, it separates out as white PPT, and this precipitate is then separated by filtration. The precipitate is then washed with water and then it is dried between folds of filter paper to obtain sodium bicarbonate. Now students, commonly this sodium bicarbonate is called baking soda. It's called baking soda, and this baking soda is a constituent of baking powder. So students, this was our discussion about preparation of salts. That is all for today. Thank you students.